Hi, Kevin from BCIT here again. We're going to do voltage divider circuit part 2. Okay, what we've done now is we have connected this point in the circuit to ground, right? I have drawn in other grounds and connected to them to these points throughout the circuit. When you see this symbol, it means that all these points are at exactly the same potential. There is no potential difference between all of these. So, if I look at point A, what is the potential difference between point A and ground? Well, it looks like it's right at ground, doesn't it? Therefore, it is 0 volts. What about point B with respect to ground? And remember that this ground is the same as that ground. So what is point B with respect to ground? Well, it is 40 volts. What is point C with respect to ground? Well, 80, 40, 120. Point D with respect to ground. And remember that this ground is that ground. They are at the same potential, right? So what is point D with respect to ground? 20, 80, 140, correct? What about point E with respect to ground? Well, it's basically the voltage across here, isn't it? Voltage from there to there. 200 and 100 plus 140. 240 volts, right? So, these are all the voltages with respect to ground or common, which it is called in a lot of electronic circuits. You will see it referred to as common. So those are the voltages with respect to that point. Now, I can change where I ground this circuit, right? So I'm going to do this stuff here for the moment. And I am going to change my ground or common point. I'm going to take that out of there. Let's say we ground this circuit at C. Nobody said we couldn't, so we're going to do it. That is the ground. What is the voltage at E with respect to ground? Well, it is going from positive to negative, so it's positive 100, 120 with respect to ground. What is the voltage at point B with respect to ground? Right? We're going negative to positive here. And we're going, how much voltage drops across here? 80 volts. So B with respect to C is negative 80. So let's just write those down. What did I say first? What is E with respect to C? E. And we'll just write WRT. For with respect to C equals E with respect to C is 120. B with respect to C. Well, this is a negative to a positive, so it's actually a negative voltage. Now, don't let that fool you. And at this point, C is our, right? Negative 80 volts. Okay? You turn the leads on your meter the other way, you'll get a positive 80 volts, right? So let's just change the common, just to see. It doesn't matter where we put it. It does not change the potential difference between 2 points. It has no effect on it at all. Well, what about E with respect to D? WRT means with respect to D. I'm just gonna, we don't always write it that way, I'm just saying, using that for the moment. E with respect to D, positive to negative. How much voltage across here? 100 volts, right? How about one that we just already did? E with respect to C. $100, 120. It does not matter where this is. We still get the same value as we got up there. What about A with respect to D? Anybody know? A with respect to D. First of all, is it a negative or is it a positive? It's going from negative to positive. So if we put our positive lead here and our negative lead here, we will get a negative answer, will we not? So A with respect to D equals 40, 80, that's 120, 140, but it'll be a negative 140, will it not? It will. Okay, there you go. So wherever we move the ground or the common, we talk about what the voltage is with respect to that point. It still does not change the circuit. The circuit is still the same circuit.